Alright, accelerated breakout, lesson B3, solving equations algebraically and graphically. Let's take a look at the first example here. So we've got a pretty straightforward example. We need to solve this equation. We have some denominators here. In order to get rid of the denominators, since the numbers are different, what you want to do is you want to find the common denominator for both of these denominators. So in that case, that would be 12. So multiply all the terms by the common denominator of both of these denominators. And over here, just because that's a 2, alright, it's not a fraction, doesn't mean you don't multiply by the 12, so don't make that mistake. I see that sometimes. So you've got to multiply all these terms by 12. So then what happens, the reason why we do that, because that gets rid of your denominators. So the 3 here and the 12, they divide out. That gives you 4. So 4 times x is 4x. 4 and the 12 divide out, that gives you 3. Positive 3x times 3. Always pay attention to these signs. You get positive 9x is equal to 24. Combine like terms. 13x is equal to 24. Divide by 13. X is going to be 24 over 13. Alright, so a real straightforward problem, nothing complicated. Alright, so let's take a look at number 2 here. So we need to solve this rational expression. Right? You guys did some problems like this in the summer. If you recall, the first step, you need to factor the denominators out. So over here, it looks like we need to factor this. Right? So that's the difference of squares. That's just going to give you x plus 2, x minus 2. And then once everything's factored out, our next step, we need to find the common denominator, or the LCD, the least common denominator. So we're going to find the LCD. Right? Now to find the LCD, you look at all the terms in the denominator, right? The LCD has to have all the different terms, okay? And if a term repeats, then you keep the higher exponent, right? So we have an x minus 2. There's one of our terms. We have x plus 2 in the denominator, another different term, right? And then over here, we have an x plus 2 and an x minus 2. So we've got those already. Now, what you're going to do next is, once you find the LCD, you multiply all these terms by whatever the LCD is. Okay, that's what you do when you're solving. So since we've got 1 over x minus 2, you're going to multiply that by whatever the LCD is. Right? In this case, it'll be x minus 2, x plus 2. Right? And then we've got is equal to 3 over x plus 2. So we're going to multiply this by the LCD also. So x minus 2, x plus 2, right? And then we've got minus 6x over x plus 2, x minus 2. And hopefully you see why we do this, right? Because when we multiply by the LCD, what it does is it gets rid of your denominators for you. So after you do this step, you should not have any more denominators after you simplify. So over here, the x minus 2's, hey, they divide out. So you're left with basically 1 times, we have 1 times x plus 2, right? So basically that's just going to give you x plus 2. Over here, the x plus 2's, those divide out, so you're left with 3 times x minus 2. That's basically what's happening. So we get 3x minus 6, right, after you distribute. Over here, well, the denominators cancel out those, so all you're left with is just minus 6x, right? Always pay attention to the sign. Don't lose signs. And then we just simplify the rest of this. That's just going to give us x plus 2 is equal to, that will give you negative 3x minus 6. Then let's move this guy over here, so that would give you 4x is equal to minus 2 over here, negative 8. X is going to equal negative 2. Okay, so we've done all the work and we found out what x is, right? Now, you need to always, when you're solving equations, to check your answers, okay? So even though we've done all the work, it's correct, we've gotten this answer. This may not be the answer. Let me explain to you why. Remember, there's something we don't want to do in math ever, and that's divide by 0. So if our answer is x equals negative 2, you notice here in the original problem, right, if you plug in negative 2 right here, right, negative 2 plus 2. Well, that makes what? That makes 0. We can't take 3 divided by 0. So what that means is, even though we did all this work right, and this is our answer, when you check your answer, it results in division by 0. Any answer that results in you dividing by 0 in the problem, that means that you cannot have that as an answer because we can't divide by 0 in math. So this is what we call an extraneous solution. So you cannot count this solution, right? So even though this was our answer, we checked it, oh, we're dividing by 0. We can't have that, so we can't count this answer. So since that was the only answer we had and we can't count it, that means this problem has no solution. Okay? Graphically, I want you guys to understand what the answer means graphically. So here's all the work. The answer was x equals -2, right? But then it ended up being no solution because it's extraneous. Now over here, remember when you have a system, if you were to graph this problem, right, which means you graph this right here, 1 over x minus 2, and then you graph this over here, which is this graph here in pink. Think of what happens at x equals 2, right? Here's 2 at x. You notice the graphs, are they're never going to touch each other, right? We have, a vertical asymptote, right? We're going to have a vertical asymptote. The graphs will never touch each other. Remember, in order for a system to have a solution, they have to cross somewhere. Well, these graphs are never going to cross each other. That's why there's no solution, right? So your algebra work and the graph, all right, they should always make sense to you. Okay, oh, my answer is no solution. That means that if I were to graph this, the graphs should never touch, or they should never cross each other. Okay. All right, let's take a look at the next example here. So we need to find the x and the y-intercepts of this. Okay. So you guys need to remember this. If you need to find the x-intercepts of anything, of any function, it doesn't matter what it is, you're always going to make y equal to 0. If you need to find the y-intercept of any function, of anything, it doesn't matter what it is, you always set x equal to 0. Okay? So over here, to find the x-intercept, we make y equal to 0. So let's just plug that in. Plus 3 times 0 is equal to 5. That's just 0. So x is going to be 5 over 2. Right? So the x-intercept, what's our coordinate? X is 5 over 2. Y is 0. For the y-intercept, right? The y-intercept, x is 0. Let's plug that in. 2 times 0 plus 3y is equal to 5. So y is going to be 5/3. So the y-intercept is going to be x is 0, y is 5 over 3. All right, so take a look at number 4 here. So we need to find the solutions of this graph right here, this function. So we have 2x to the third minus 3x plus 2 equals 0. So you're going to graph this. Okay, so this problem already equals 0, so that's nice. So what you can do is you're going to graph this in your graphing calculator, right? So basically you're graphing y is equal to this right here. Okay, so let's graph that. So you graph it and you get something that looks like this. Okay, now remember we had this is equal to 0. So where's the y0? Y is 0 here, right, based on the x-axis. So where does this graph cross the x-axis? Wherever it crosses the x-axis, that's your answer right there. So use your calculator. You're going to have to approximate that. So it turns out x is equal to negative 1.475687, and that would be your answer. Okay? Number 5 here, pretty much the same thing. All right. So first thing you want to do is you want to make this, to make it easier for yourself, you want to set this equal to 0. So x squared minus 5x plus 3 is equal to 0. So you want to graph this right here. Okay, so you want to graph in your graphing calculator x squared minus 5x plus 3. Okay, so let's do that. So we graph x squared minus 5x plus 3. Well, remember our solutions, right? Remember this equals 0. So basically, where does it cross the x-axis at? It crosses the x-axis right there and right there. So just use your graphing calculator and find the 0. Use the 0 function and find those values right there. And then that'll be your answer. Okay, so it turns out the answers are going to be, so the y values, the x values, x is going to equal 0.697, and over here x is going to equal 4.3027. Okay, so those would be the values where the parabola crosses the x-axis. Alright, so let's take a look at number 6 here. Finding points of intersection. Okay, points of intersection. So over here, what you want to do first is you want to graph these two functions, right? So in order to do that, let's get the y by itself. So let's see. Get y by itself here, so we're going to end up with negative 3y is equal to negative 2x minus 2 divided by negative 3, right? So we end up with y is equal to 2/3 x plus 2/3. Same thing over here, I'll just move the y over there. We get 4x minus 6 is equal to y. So basically you're graphing this right here and you're graphing this right here. Okay? So let's see what that's going to give us. Alright, so once you've graphed it, so we have our two functions here. So we're trying to find the intersection. So where do they cross at? They cross right here. So what you want to do is you want to use the intersection feature of your graphing calculator, and that will give you the x and the y coordinates where they cross. So in this case it's at 2, 2, right? Alright, so the next example, so we're trying to find the intersection of these two graphs right here. So let's graph them, okay? See what we get. So we graph the two functions right here, and it looks like they intersect right here at this point. Okay, right here at this point. So you might want to zoom in a little bit to find out what that value is. You kind of don't have to, but use the intersection feature of your graphing calculator to find the x and y values of the intersection there. So if we do that, we're going to end up with, looks like where they cross right here, x is negative 2.17, y is 7.24, so these would be the coordinates of your intersection. Okay. Alright, so let's take a look at example 8 here. So we need to solve this polynomial equation by factoring. Alright. So first thing I notice here is, remember when you're factoring, alright, you're solving and you're factoring, you always look for a GCF, and it looks like we do have one, so we could take out a 2 here, right? So then that's going to give us x to the third minus 3x squared minus 3x plus 9 is equal to 0. And basically, if you divide by 2 on both sides, right, now these divide out and you're left with just this, x to the third minus 3x squared minus 3x plus 9 is equal to 0, right? Next thing, well, I notice I've got 4 terms. So last year, you probably learned a method where, hey, if you have 4 terms, you want to try factoring by what we call grouping, right? So if we group these together, let's see if this works. So we have x squared, take out the GCF from these two, right? So we get x squared, that'll leave us with x minus 3. Over here, it looks like we could pull out a negative 3, that'll leave us with x minus 3 is equal to 0, right? So in this case, factor by grouping does work. So how do you know when it works? These must be the same. If these are not the same, then factor by grouping doesn't work, or you might have to try a different grouping. Okay, so these must be the same. So now what you want to do next is take your GCFs, all right, group them into one factor, and then the x minus 3 that repeats, you just need to write it only one time. Okay? And then we want to know, hey, when is this going to equal 0? Well, if this is multiplying with this, when this equals 0, when x squared minus 3 equals 0, the whole problem is going to equal 0, right? Or when x minus 3 equals 0, or when x minus 3 equals 0. Well, so this one's easy. X is going to be 3 for that one. Over here to solve that, x squared 3 square root, x is going to equal plus or minus radical 3. Okay, so here are all your solutions. Okay, so what does this mean? This means that if you were to graph this right here, the graph should cross the x-axis at these values. Alright, so you guys need to understand what it means when you guys are finding the answer. If you were to graph this, the graph of this will cross the x-axis at positive 3 and plus minus radical 3, which is, some sort of decimal 1 point, something. So let's graph it just so we see. So we graph the problem here, and right here, So at 3, 0, or at x equals 3, the graph crosses the x-axis at 3. And over here at positive radical 3 and negative radical 3. Okay, these are decimals, right? Radical 3, if you estimate that as a decimal, if you 1 point, something, right? You throw that in the calculator. Alright, so we need to solve this problem now. Alright. Now, even though this is x to the 4th power, just looking at it is basically, you could factor this kind of like if it was a quadratic, right? So basically, you could have x squared minus 2, x squared minus 1 is equal to 0, right? And let's just double check to make sure if we multiply this, it gives us this. So you multiply here, that gives you x to the 4th, negative 1x squared, negative 2x squared, that's negative 3x squared. And you multiply here, that'll give you positive 2, right? So if you FOIL this, you actually do get this. So we factored correctly. So then when is this going to equal 0? Well, that's when x squared minus 2 is equal to 0, or when x squared minus 1 is equal to 0. So x squared is equal to 2, square root both sides. Alright, don't forget the plus minus. Okay, plus minus, we're at 2. Over here, x squared is equal to 1, square root both sides. So x is equal to plus or minus 1. So these are our solutions right here, right? And this was a pretty nice problem because we were able to factor, right, this 4th power, polynomial, right? Like if it was a quadratic, right, and just solve it. But sometimes if you can't factor this, right, let me just show you what you would sometimes have to do if you cannot factor this and solve it this way. So here was the problem that we had, right? And remember, we were able to factor this, right? We were able to factor this, x squared minus 2, x squared minus 1 is equal to 0, right? But if you're not able to do this, here's what you guys have to kind of recognize, right? So let's say it was kind of like a different problem with some different numbers. What happens is, you notice here this x to the 4th and this x squared, if you treat this, right here, if you make this x squared to the 2nd power minus 3 times x squared, right? So this is the same thing as this, okay? Now you notice what you've done here is you've made this into a quadratic, right? You've made this right here into a quadratic, where basically here's your A, your B, and your C, right? So since you've kind of rewritten this in quadratic form, you could use a quadratic formula. So problems where you cannot factor this like this and find the answer, you might have to rewrite it in quadratic form, kind of like this, and then find your A, B, and C and use the quadratic formula. Okay? Just something I want to show you guys and point it out, just in case you come across a problem where you wouldn't be able to factor it. Okay? Alright, so let's take a look at this example here. So you've got a radical equation. Okay? So the first thing you want to do is when you have an equation where you have a radical and you have the letters, the variables inside the radical, you want to get this radical by itself. So we're going to add x to both sides. So we get a radical of 2x plus 7. It's going to equal x plus 2. And then you want to get rid of this radical. You square both sides. So this and this cancel out. So we get 2x plus 7 is equal to, FOIL that using our shortcut, x squared plus 4x plus 2. Now, hey, we've got a quadratic, and we're not going to be able to get rid of this x squared, so we've got to set the problem equal to 0. So we get x squared, all right, minus 2x minus 7, so minus 2x minus 7. So we're going to, oops, over here it should be a 4. Got that. So we get x squared plus 2x minus 3, right? So over here we end up with x plus 3, x minus 1. So when is this going to equal 0? When x is equal to negative 3, or when x is equal to 1. Now, when you're working with radical equations, you always want to check your answers, right? So just as you get some answers doesn't mean they're right. So we plug in the negative 3 into the original problem. So square root of negative 3 times 2, that's negative 6, plus 7 minus negative 3. Does that equal 2? It has to give you 2. So, well, it doesn't give you 1. The square root of 1 is 1. It gives you plus 3. Well, does that give you 2? Nope, it doesn't. That means that this is an extraneous solution. Do not count it. Okay, let's check the 1. Let's plug in 1 here. Well, that's going to give you square root of 2 plus 7, which is 9. So that'll give you 3 minus 1. Does that equal 2? Yep, 3 minus 1 is 2. So this answer checks out. So that's our answer right there. And let's just understand what this means graphically. If we were to graph this, right? Let's take a look at what the graph looks like. So here's the graph for it. You notice this problem, right? This function here, it only crosses the x-axis at 1, right? It didn't cross at -3. Remember we had that extraneous solution? You notice it only crosses at +1 right there. Okay. So our algebra work and the graph, it makes sense. Okay. All right, so let's take a look at the next example here. All right, so we've got 2 radicals. Well, if you've got 2 radicals, just get one of them by themselves. So we're going to just get rid of this right here. So we'll add radical x plus 4 to both sides. So we add radical x plus 4. All right, so then we get rid of that. So we get square root of 2x plus 6 is equal to 1 plus square root x plus 4. Okay? And then the next thing what you want to do is, well, remember we want to get rid of this radical, so we square both sides. Make sure you guys put the parentheses, square both sides. So that gets rid of that. Right, so we end up with 2x plus 6, so that's nice. Over here, right, so it's up to you. You could, I mean, I would write this out like this if you're not comfortable following my pattern. Right. So you could write it out like this, or you could follow the pattern that I taught you guys last year. So basically we have, well, I'll do it with the pattern first. So the pattern says we square this first term, so 1 squared is 1. You multiply these two and double it, so you multiply 1 times this, that would just give you this radical x plus 4, and you double it, so you get positive 2 square root x plus 4. And then you square this, well, you just square this, that's just going to give you plus x plus 4. Right. Now, if you just, and if you're not comfortable, following that pattern, or if you didn't know it, or you forgot it, just write this out twice and work it out. 1 times 1 is 1. Multiply here, that's positive radical x plus 4. Multiply here, that's another positive radical x plus 4. And multiply here, that gives you plus x plus 4. So you end up with 1 plus 2 radical x plus 4 plus x plus 4. Right, so same thing as this. So let's simplify a little bit on this side. So we're going to end up with, so 1 and then the 4, that's going to give us what? 5 plus 2 radical x plus 4 plus x, right? So now what you want to do is you want to get this radical by itself, right? So we're going to get rid of this stuff. We're minus the 5 minus the x. So minus the 5 minus the x. So that's going to leave us with x plus 1 is equal to 2 radical x plus 4. Okay, now it's really up to you. You can get rid of this 2 by dividing both sides. But what's going to happen over here as well, you're going to get a fraction. So I would just leave it there for now. So what I'm going to do is, well, I'm going to get rid of this radical. So I've got to square this whole thing, right? So I'm going to square this whole thing. So I'm going to follow the pattern again. X squared plus 2x plus 1. That's what I'll get here. Over here, don't forget to square the 2. So 2 squared is 4. And then when you square this, that gives you x plus 4. So when you distribute, we're going to end up with x squared plus 2x plus 1 is equal to, distribute that, 4x plus 16. We've got a quadratic, let's set it equal to 0, x squared minus 4x minus 16. So we're going to end up with minus 2x minus 15 is equal to 0. So let's factor this. So hey, that's x minus 5, x plus 3 is equal to 0. So when is this going to equal 0? When x is going to equal 5, all right, or when x is going to equal -3. So those are your 2 answers. And once again, remember, you always want to check your answers. All right, check your answers, take the 5, take the -3, plug them in, see if they give you 1, okay? So you graph it, it turns out the 5 works, right? Because you notice the problem, it crosses the x-axis at 5, but it doesn't cross at -3. So if you were to check -3 by plugging it in here, it's not going to give you, right, the correct answer, right? So when you check -3, go back to our work, right? The -3, if you plug it into the original problem, it's gonna be an extraneous solution. It will not give you 1. Okay, so it won't give you 1. Another thing, keep in mind when you're graphing this here to check your answer on a graphing calculator, you want to -1 on both sides. So you have this -1 equals 0, and then you want to graph that on the graphing calculator to check your answers. Okay. All right, so let's take a look at this one. All right, so we've got an equation in rational exponent form. Now remember, you can always change this to a radical if you want. This really means what? It really means the cube root of x plus 1 squared is equal to 4, right? These two problems mean the same thing, okay? So let me show you how to work with it when it's a rational exponent right here. So what you want to do is, well, you've got x plus 1 to the 2/3 power is equal to 4. Well, all you have to do is, since this is already by itself, right? You always want this by itself first, so sometimes you have to do some stuff to get this by itself. You want to make sure this is by itself, and then you're going to raise to the power of the reciprocal. So you do 3/2. So 3/2. So the reason why you do that is, hey, all these divide out, that just gives you 1, right? So you get, x plus 1 now, no more exponent. So that's the reason why we do this step. Now here's the thing you have to remember. When you raise to the power of both sides, if the denominator is any even value, right, 2, 4, 6, 8, and so on, if the denominator here is even, you need to have a plus minus, right? Because what that means is, remember when you had an equation and you square root both sides, and then you would need the plus minus. Technically you're doing the same thing here, right? Because 3/2, this means that you're square rooting this, right? So over here, so let's simplify this. Now remember, there's a few ways to do this. You can change this to a radical. This means the square root of 4 to the 3rd. What's the square root of 4? 2 to the 3rd power, so that would give you 8. Right, so that's one way to do it. Or the other way, you could do 2 squared to the 3/2 power. And hey, when you multiply exponents, what happens? The 2's cancel, 2 to the 3rd, that gives you 8. Right, so you minus 1. So what are our two solutions? Positive 8 minus 1, negative 8 minus 1. So we end up with 7 and negative 9. All right, and once again, you always want to take your answers, plug them in, check them, right? So take the 7, plug it in, work it out, see if it gives you 4. Take the negative 9, plug it in, see if it gives you 4. If it doesn't give you 4, then it's an extraneous solution. All right, so make sure you guys check your answers. All right, so we have to graph it to check our answers. So it looks like the graphs cross at negative 9 and 7. So it looks like both answer choices worked out. All right, if you do the check, right? All right, so example 13 here. Pretty straightforward, right? We just need to find the LCD, right? So our LCD, least common denominator, looks like it's going to be x times x minus 2, right? So we're going to multiply everything, right, by x times x minus 2. 2 over x multiplied by our LCD, x times x minus 2. 3 over x minus 2 multiplied by our LCD, x times x minus 2, minus 1, right? And we still need to multiply by our LCD, x times x minus 2. So let's do that. So the x's here divide out. We end up with 2 times x minus 2 is equal to, the x minus 2 is divided out. We get 3 times x, which is 3x. Over here, you have 1 times x, which is just going to be, x. So just make sure you guys pay attention, that's negative there. So over here, this is x squared minus 2x, right? If we distribute this, times the negative 1, so it doesn't give you negative x squared plus 2x. We've got a quadratic. We have a quadratic here. Let's set it equal to 0. So over here we have 2x minus 4. So if we set it equal to 0, it looks like we're going to minus 2x, add 4. So let's simplify all this, right? So we're going to get negative x squared. That'll give you x plus 2x, so it'll be plus 3x. Then we have plus 4. Then let's solve this. What I'm going to do is I'm going to factor out that negative 1. X squared minus 3x minus 4. And 0. Let's factor this. X minus 4. X plus 1. So we're going to end up with, when is this going to equal 0? X is going to equal 4. X is going to equal negative 1. So you want to check your answer choices here. All right, your answers. Plug in. Are we going to divide by 0? No. Plug in the negative 1. Does that make division by 0? No. So both of these answer choices, all right, are okay. All right, so we're trying to solve an equation that deals with absolute value. Okay, so in order to do that, what you're going to have to do is you're going to have to rewrite this problem so that it doesn't have the absolute value bars. All right, so we call that redefining the problem using the definition of absolute value. So what you're going to do is the first equation is going to be the exact same thing. All right, whatever's inside here, just copy it down. Is equal to, negative 4x plus 6. Here's our first equation. So basically it's the same thing, just without the absolute value. Now, the second equation, whatever's inside here, right, it remains the same. But you're going to have a negative version of it. So negative, parentheses, x squared minus 3x, okay, is equal to negative 4x plus 6. Right? So here are the two equations that we're going to solve. So let's do the work. So over here, it looks like we've got a quadratic. Let's set it equal to 0. X squared, if we add 4x, that'll give you x minus 6 is equal to 0. Let's factor x plus 3, x minus 2. So it looks like our solutions for this one's going to be negative 3 and 2. Over here, so we distribute the negative x squared plus 3x. And then let's set it equal to 0. So I'm going to move all this stuff over here. So 0 is going to equal x squared, and a minus 3x, that could be minus 7x plus 6. Let's factor that, x minus 6, x minus 1. So x is going to equal 6 and positive 1. So what you want to do is you want to check all these answers. So take this, plug it into the original problem, see if the left side and the right side is going to be the same. All right, take the 6 and the 1, plug it into the original problem, see if the left side and the right side is going to be the same. Okay, and the ones that verify, right, those would be your answer choices. Maybe all 4 will work, maybe only 1, maybe only 2, maybe only 3, who knows, right? But if we were to graph this, we'll see our answer choices real quick, right? Our solutions. So if we actually graph the problem, it turns out only the graph crosses the x-axis at negative 3, all right, and at positive 1 on the x-axis. So those are your answer choices that work, negative 3 and positive 1, right? So the negative 3, so if you were to actually do the check algebraically, the negative 3 works and the positive 1 works. So it looks like it turns out that the 2 and the 6 doesn't work when we do the check. Okay? So, because that's what the graph kind of tells us right there.